Okay, so instead of dark matter and dark energy, we will have to settle for dust. So why is that even interesting? Well, I hope to convince you, and to do that, I will also make this a story about discovery, because astronomy is, since the first person looked through the first telescope, has been very much the history of discovery. And that started in 1612 with Galileo, and that is still going on now. So let's go back to 1612, to Galileo. He is one of my heroes, so that's why I usually in talks like this like to spend some time on him. He has this telescope in his hand here. Now, why is he my hero? He didn't even invent the telescope, right? Does anybody here know, no astronomers please, who actually invented the telescope? See a hand there? No, not Huygens, no. There's a man named Hans Lippershey. Has anybody ever heard of him? Okay, so unknown, not well-known person. He's a footnote in history. And why did Galileo become famous for the telescope? Because Galileo was the first one to actually point a telescope at the sky. Lippershey was in a totally different business. Lippershey made his invention and then sold it for profit for military purposes. This was in Holland. It was during the 80 Years' War. And he made a nice sum of money, and he got a footnote in history. Galileo wasn't in it for the money at all. He did something unusual. He pointed a telescope at the sky, and that was really the birth of modern astronomy. And he quickly made his classic discoveries. You've probably heard of them: the moons of Jupiter, the mountains on the moon, the fact that the Milky Way consists of stars, and most importantly, the phases of Venus. And I'm going to actually explain this to you, and then challenge you to repeat his discovery, so that you get a sense of what a discovery, an astronomical observational discovery is. So here is a picture of our Milky Way with the Earth and Venus, and you can see this is in a modern picture where everything is revolving around the sun. But in Galileo's time, of course, people thought the Earth was stationary at the center. So you have Venus, and you can see you can have a full Venus, then it's behind the sun. But if it's close to us, then you get this little crescent, right? And you can immediately see what happens. If you have a full Venus, it's far away from us, so it's got to be small, right? And you have this little crescent Venus, then it's big. And this is what Galileo observed here. This is from his book, the pictures of Venus, a very big crescent Venus and a very small full Venus. Now, this was with a little telescope with only 2 lenses. If you have a pair of binoculars at home, you can do this better than he did, right? So Venus is visible as a bright object just after sunset or just before sunrise. And I challenge you to do this, because it is instructive. And then remember, at that moment, you are actually a cosmologist. You are thinking about the structure of the universe, and you're doing an experiment, a scientific observation, and you can do the same thing as Galileo. So I really urge you to do that. So then time marched on, telescopes became bigger and bigger, but it is a story of observation and discovery. So let's now fast forward to the present day, almost. Remember this one? This is Donald Rumsfeld in 2002. Here he is talking about weapons of mass destruction. So what does that have to do with astronomy? Well, during a speech he said this, and it's written down here in the form of a poem. It is poetic, in spite of himself, and it's also a very good theme for astronomy as an observational science. So I'll read it to you. So, as we know, there are known knowns. There are things we know. That's poetry. We also know there are known unknowns. That is to say, we know there are some things we do not know. But there are also unknown unknowns. The ones we don't know, we don't know. And that's what Galileo was doing. That is observational discovery. You have a new technique, a new telescope, a new instrument, a new camera. You point it at the sky, And you've probably made it for some reason or for some excuse, but you are going to discover something. So, a modern example now of that, which is related to dust. So this is a dusty galaxy. Our Milky Way is dusty too. You can see clouds of dust if you look at the Milky Way on a clear night. You see this diffuse light, but there are dark patches in it. Those are not holes in the Milky Way. Those are dust clouds. So you can actually see them. And this is a particularly dusty galaxy. You can see the dust clouds very clearly. This object is named R220. And we can actually measure how much dust is here. So the dust here basically looks like a nuisance, right? It is just in front. It's blocking our view. But how much of it is it really blocking? Is that, is it 10% that we missed? Does anybody want to guess? How much of the light of this object is blocked by the dust? Percentage? 10? No. 70? No. It's 99. 99% of the light is blocked. And you can't tell that from this picture, right? So how do we know that? Well, we can actually measure the glow of the dust, and I'll come back to that. So here the dust absorbs light, but we can measure the glow of the dust. So to put a number on this, so for the astronomers in the audience, the amount of dust here is 10,000 visual magnitudes. So to translate that into everyday language, if I was to compress that amount of dust into the density of rock, I would have a layer of rock of 30 centimeters thick. So that's what you would have to look through to actually see into this galaxy. So then you can understand that there's 99% is missing, and actually if you realize that, you're surprised that actually 1% of it gets out. So, and now the question is, of course, are there galaxies that are so obscured, so dusty, that you don't even see them at all with invisible light? And so that's the unknown unknown. So here's a field of galaxies. This is the Hubble Ultra Deep Field, a famous picture from Hubble Space Telescope. So thousands of galaxies. You see a few big ones, those are nearby. You see a lot of small ones, those are farther away. There's a zoom in. There's a zoom in over there where you can see that even the tiniest speck is a galaxy of about 100 billion stars. So the question is now, is this all there is, or are there hidden galaxies? Galaxies that are so dusty that you don't see them even in these exquisite images? And the answer is going to be yes. And not only that, the second answer is going to, or the implication of it is that it's also going to be very important. So, as I mentioned, you can detect the glow of the dust. So I showed here a beautiful picture of the Milky Way with its dust clouds. And here is a constellation. Which one is that? Orion, excellent. So in visible light, you see the stars. But there's a lot of dust in Orion. And the dust glows. It glows in the infrared. So if you use infrared radiation, this is the picture of Orion. So it's totally different. Very spectacular region. And the dust glows, of course, because it's heated by starlight. So it's just like if you're walking in the sun with a black shirt on, your shirt gets warm. So it's heated in that case by the sun. That's also starlight, and then you could detect it with an infrared camera. So we can actually observe dusty galaxies by going to the infrared. And so this is the Galileo analogy. This is our new technique, or at least it was our new technique in 1997. This is when this story plays out. That we use to discover or to search for dusty galaxies. And this is the only spectrum that I'm going to show. But this is the most important spectrum that you'll ever see, because this is the spectrum of the universe. So, and the reason that I show this is that you see now the light that is emitted by the universe as a whole, but raveled out, uitgerafeld, dispersed into different frequencies or wavelengths, and you see different components. Here is the microwave background. That's the afterglow of the Big Bang. So notice it's the highest component of everything. So most of the energy in the universe, most of the radiation in the universe is actually still from the Big Bang. And then this thing comes. So there are two peaks here. There's one in the infrared, dust emission, and there's one in the optical, starlight. And you can see the starlight and the infrared, the dust emission, the glow of the dust, are comparable. So that tells you that these dusty galaxies must be there, and they are as important as the optical galaxies, as the galaxies that we see. So with that in mind, and inspired by that, we set out in 1997 with a new technique to observe the infrared emission from these galaxies from Hawaii. So this is the James Clerk Maxwell telescope at Hawaii, very high on top of Mauna Kea, dormant volcano. So this is the view from the telescope. Over there you can see the neighboring volcano, the Kilauea, which erupted last year actually. And I'd like to tell this story here in a little bit, in a personal way. This was my first visit to Hawaii and my first use of this telescope. And I had an approved observing program to look for the unknown, right? To look for distant dusty galaxies, which we didn't know whether they existed or not. So it might have been a total failure, right? It will not be, but I'm going ahead of myself now. But it might have been a total failure. So it is a good habit among astronomers who visit Hawaii for the first time for observations to be respectful of Mauna Kea, which is a sacred site of the Hawaiian people, and you can be respectful by paying homage to the goddess of fire on Hawaii, Pele. So I actually did that, and I went to the Kilauea crater, which was not erupting at that time, and I actually laid a flower on the edge of the crater. You never know. And actually, my observations were extremely successful, because I was just lucky. The weather was fantastic, the instrument was working, and I'll show you the result of that very first observation. So this is a field of galaxies in visible light that I looked at to look for dusty galaxies, right? And you see a lot of big galaxies here. There are also some funny arcs, so that's a different story here. But keep, let's see, a good reference point. So a good reference point is this blue object. This blue object over here, so keep that in mind. And what I'll show you next is the same picture in a little bit different color, but now overlaid with the infrared emission that I observed. So here is the picture again. So the big galaxies, the blue object that I pointed out sits over here, and these contours here, 1, 2, 3, 4 blobs, are the infrared emission. So there are 4 infrared galaxies there with no optical counterpart. Well, one has an optical counterpart here. There's a very red object here. So close to this blue object, there's a very red tail. It's a different galaxy. So there's a little bit of emission there. If you look very carefully, there's a little bit here as well. But here there's nothing. Invisible galaxies. And not only that, they're extremely luminous. They're monsters. They are not your normal small galaxies like your everyday galaxy that you find everywhere here. So we are really looking at monsters here. For those of you who were here last month when Jackie Hodge was giving a talk, she was talking about these monsters of this type. So I'm not going to go into the details of that, but this was our first glimpse at the dusty universe. Now, how important is this? Is this just a detail? No, it's actually very important. And this is my last picture. So why is this important? The reason is the following. So what is, this is a little bit complicated. I'll walk you through it. What is plotted here is when the stars that we see in the universe formed. So this is where we are now, redshift 0, that is here and now. And over here, somewhere over there, is the Big Bang. So time, cosmic time, goes from here to here, right? And then on the vertical axis is how much stars are being formed in the universe per unit of time, so per year, and per unit of volume. So in other words, how busy the universe is forming stars at that particular cosmic time. And you can see it starts out fairly modestly, and then it goes to a peak, and then it dies down again. Right? So we are, as I said, we are here. So we are in a stage where the universe is past its prime, right? So it's sort of the aging universe. The universe is about to retire. It's just like, well, I was going to say just like me, but that's not. This is right, and we call this cosmic noon. Then, so this is where all the action is, right? So redshift 2 to 3. So that's more than halfway back to the Big Bang. And yeah, and then of course, if you go towards the Big Bang, further back in time, then the universe gets less active. Now, why are the dusty galaxies important here? If you were to make this diagram with only the visible light, you would get this, the blue curve. If you include the dusty galaxies, you get the yellow curve. They dominate. Most of the action, most of the star formation in our universe happens in obscured places. You don't know where the action is if you are blind to infrared radiation. It is absolutely crucial. So, and it is crucial now, it was crucial at cosmic noon, but now something interesting happens, and this is, now we're in our modern era. This is recent, this is from a paper from last year. So see here, now the optical and the infrared curves coincide, or to put it differently, the infrared doesn't add anything to the optical anymore. So we are approaching, at those very, very high redshift, those early times in the universe, the time when dust had not formed yet. And therefore, there we can actually use visible light, which is then again redshifted into the infrared, but that's a technicality. So if it's the bottom line is, if it's not in the infrared, you cannot do cosmology. And this is the discovery, so to speak, of last year. So this will continue. This part here will get a lot of attention with the James Webb Space Telescope, with the extremely large telescopes, and is already being studied with ALMA in Chile. So it's discoveries since 1612, and these discoveries are ongoing and will be ongoing as long as we develop new techniques, and I hope that's going to be a long time. Thank you very much.